It's coming, sir. Hello, students. Greetings. Today we shall discuss the exam paper we shall attempted today on that is on 22nd. The first question is the polytropic index is 0 for process. What is polytropic process? Like PV power gamma is equal to constant, and he's saying that the gamma value is 0. If this is 0, can I simply write it as PV power is equal to C? If PV is equal to C, then what is it? PV is equal to constant, so it is constant pressure. And coming to second question, in an adiabatic expansion of 1 mole of the ideal gas, the initial and final temperatures are T1 and T2 respectively. The change in the internal energy of the gas. And we know that what is the work done? The work done in adiabatic processes are T1 minus T2 divided by are T2 minus T1 divided by 1 minus gamma. But we know that in adiabatic process, the change in internal energy is equal to negative of work done. So this would be equal to minus R T2 minus T1 divided by 1 minus gamma. Negative multiplied in the denominator will give us gamma minus 1. So this would be R into T2 minus T1 divided by gamma minus 1. It is option 1. Going for question number 3. The equilibrium state of the thermodynamic system is described by. We know that it is described by pressure, temperature, and volume. So it is A, C, and D. It is option D. Going to question number 4. See here, the equation for real gas is given by P plus A by V square into V minus D is equal to RT, where P, V, T, and R are pressure, volume, temperature, and gas constant respectively. The dimension of A, B power minus 2 is equivalent of that of. So we are supposed to find the dimensions of A, B, and B initially, and then we shall try to solve the given question. What is the dimension of A? And we shall try to dimension of A by V square has to be equal to the dimensions of the pressure. Similarly, the dimensions of B should be equal to the dimensions of the volume. So the dimensions of volume will be equal to the dimensions of B, which is equal to L cube. And what is the dimensions of A? The dimensions of A by V square is equal to dimensions of pressure. What is pressure? Pressure is force per dimensions of pressure. Pressure is force per unit mass L ml T power minus 2 . This is pressure. So what is volume? Volume is L cube. So if you multiply this by L cube, L cube whole square is L power 6. So the dimensions of A would be equal to m into L power minus 1 into T power minus 2 into L power 6, which implies m into L power 5 into T power minus 2 is the units dimensions of A. Now what is he asking? He is asking us to find the dimensions of A into B power minus 2. What is A? So A is m into L power 5 into T power minus 2, and A into B power minus 2 would be m L power 5 into T power minus 2 into what is B? B is L power 6. It would give us L power minus 6. B power minus 2. So B power minus 2 would be L power 3 into whole minus 2. That would be L power minus 6. So we can write it as m L power minus 1 into T power minus 2. And this unit would be equal to energy density. Why energy density? What is energy? Energy is m L square T power minus 2. What is energy density? Your energy, the units for energy is m L square T power minus 2. If you divide it by volume, you'll get it as L power cube. So this will be m L power minus 1 into T power minus 2. So the units of energy density and the units of AB power minus 2, they are matching. So your answer would be option D, energy density. And now going to question number 5. The uniform rod of mass M and length L is suspended about its head. The time period of small angle oscillations is. Why small angle? Always remember small angle oscillations. Why is this important? The small angle oscillations indicates it is undergoing simple harmonic motion. Now, this is a rod, and I'll consider the mass m is acting here. So your the restoring force is the the restoring force is minus mg sin theta. If this is theta, your restoring force is minus mg sin theta, and that would be equal. And what is your torque? Torque would be equal to minus mg sin theta into, and if the rod is your center of mass is exactly at L by 2 distance, so this would be equal to L by 2. So this has to be equal to I alpha. So can I simply write it as minus mg L divided by 2 into sin theta is, since your angles are very small, your sin theta will be equal to theta, which is I, which is equal to I into alpha. What is moment of inertia? Moment of inertia is ml square by 3 with respect to its end. It is not at the center of mass. Your body is rotating with respect to its head. It is ml square by 3 into alpha. So when you m gets cancelled out, L and L gets cancelled out. So your alpha is 3g by 2, 3g by 2l. And for simple harmonic motion, we know that alpha has to be equal to minus omega square into theta. So if you compare both of them, you will get it omega. If you compare both of them, you will get omega square is equal to 3g by 2l. What is he asking here? The time period. So can I simply write, if omega square is this thing, then what is your time? Time is 2 pi into under root of 2l by 3g. It is 2 pi into under root of 2l by 3, option C. Going for question number 6. A wave is represented by x is equal to 4 cos 8t minus y by 2, where x and y are in meter and t in seconds. Find out the frequency of the wave. What is frequency? So this equation in the form of, if x is equal to a cos ky minus omega t or omega t minus kx. Now, in place of omega, what do you have? Your angular frequency is 8, and what is k? The wave number would be 1 by 2. Now, what is he asking? Find out the frequency of the wave. So, if your angle omega is 8, what is omega? Omega is 2 pi by t. 2 pi by t is 8. What is he asking? He's asking what is the frequency of the wave. Its frequency is nothing but 1 by t. So, can I simply write it as 2 pi into f is equal to 8, and your frequency would be equal to 4 by pi. So, your frequency would be 4 by pi, which is option 1. Going for the next question. In the figure, the intensity of waves arriving at D from the coherent sources S1 and S2 is I0. The wavelength of The wavelength of the wave is lambda is equal to 4 meters. Find out the resultant intensity at D. So we are supposed to find the resultant intensity at D. This is one of the interesting thing. See, like both, like he's saying that the light source is coherent, in which means that the frequency, there is no initial phase difference between the light rays which are at the starting point. Because if this is a, from the figure, this is a right angle triangle, this is 3, if this is 4, this has to be 5 meters. Now this is traveling more distance than the light ray which is coming from source 1. That means that there will be some phase difference, because this is traveling more distance and this is traveling less distance. And what is the phase difference we are supposed to find? And what is the difference between the distance traveled? The light ray which is coming from source 2 is traveling 1 meter more than the light ray which is coming from source 1. So can I simply say it as, and what is the wavelength he's saying? He's saying that the actual wavelength is 4 meters. If for complete wavelength, what is the total angle? I'll say for the total phase, for if you consider that to be a circular, like a simple harmonic motion circular phase, circular diagram, reference circle diagram. So for 4 meters, your phase angle has to be 2 pi. Now, what is the difference here? Can I simply write it as the difference between the both the light rays is 1 meter. So for 1 meter, what would be the phase difference? So I'll write it as 5. So it is 5 by 2 5 is equal to 1 by 4. So it is, which implies phi is equal to pi by 2. Your phase difference is pi by 2. Now how do you find the resultant intensity? So we know that the resultant amplitude square is equal to a1 square plus a2 square plus 2 a1 a2 cos phi. And we know that your intensity is directly proportional to a square. If your intensity is directly proportional to a square, can I simply write it as your resultant intensity is equal to, since he's saying that the light ray is same in both the cases, so the initial intensities for the both the light rays will be same. So it will be I naught plus I naught plus 2 into under root of I naught into under root of I naught into cos pi by 2. Cos pi by 2. So this total value will be 0. So my resultant intensity will be equal to I naught plus I naught, which will be equal to 2 I naught. So it is option C. Question number 8. Two tuning forks have frequencies 450 hertz and 454 hertz respectively. On sounding these forks together, the time interval between the successive maximum intensities are. So it's a topic from beats. So how many? What is the beat frequency? Like the number of beats would be 454 minus 450. So can I simply say the number of beats is 4 beats per second. That means there are 4 beats every second. So what is the frequency now? So can I simply write it as 1 by 4? Every second you are listening 4 beats. So the frequency, the time period between both, like two beats will be like 2 beats would be equal to 1 by 4 seconds. So it is option A. And coming to next question, question number 9. If the clock based on simple If a clock based on simple pendulum is taken to a hill, it will become slower. With the increase in height above the surface of the earth, G decreases to T. G decreases, so T will increase. So what do we know about the time period? The time period is equal to 2 pi into under root of L by G. As you are going to the heights, what happens? The net acceleration due to gravity will decrease. If this is decreasing, your denominator value is decreasing, so the time period of the pendulum will increase. So can I simply say that if you are going onto the hill, it will become slower? Yes. If your time period is increasing, the oscillations will be slower. Right? First statement is correct. Statement 2. With the increase in the height above the surface of the earth, G decreases, so T will increase. Right? So both option A and option B are statement 1 and statement 2 are right, and statement 2 is the correct explanation for statement 1. So it is option A. Going for the question number 10. The ideal monatomic gas is taken around the cycle ABCDA as shown in the following figure, following PV diagram. The work done. It is a simple textbook problem. It is the area under the diagram. What is the area? So your length is 3p minus p is 2p, and what is the change in volume? 3v minus v is 2v. So what is the work done? The work done will be equal to area, which is equal to 2p into, it is 4p into v. So it is option C. Going for the next problem, question number 11. Select the correct statement about the reflection and refraction of the string wave at the interface between the two strings. The reflected wave has a phase difference of 90. When does the reflected wave has phase difference of 90? When the second wave is more denser. If you have two waves, if you have two strings, if this is density 1 and if this is density 2, if density 2 is greater than the density 1, then the reflected wave has the phase difference pi. But nowhere he mentioned that first is lower density and second is higher density, so we cannot say it, we cannot take it for granted. So this is only partially true, so this is not your answer. Wavelength of the reflected wave is less than the incident wave, you cannot say it. That it's also dependent on the distribution of the densities. If the second density is more, the values will be more, like the values will change. And question number 3, option number 3, frequency of transmitted wave is same as that of incident wave. What does it mean? It says that if your ray is traveling from one medium to another medium, there is no change in frequency whatsoever. It is always true even for any kind of medium. It is true for sound, it is true for light, it is also true for the waves traveling in the string. If your if any wave, if it is traveling from one medium to another medium, the only thing which remains constant is its frequency. So here the frequency of transmitted wave is same as that of the incident wave. Correct. And this is exactly opposite for the option 3. So option 4 is wrong and option 3 is right. Coming to your question number 12. If at t is equal to 0, so he's saying that at time 0, the wave pulse is given as y is equal to 10 by 5 plus x square. Find out the function representing the pulse at time t. So we know that the wave function is always the function of their displacement and time. But for us, it is given at time t0. So can I simply write at t is equal to 0, what is my function? Y is equal to, y is only the function of x because your t is 0, x comma 0. Now, if your wave is consider your wave is traveling from one point to another point, and this is at t is equal to 0. This is when t is equal to 0, and when t is equal to some time t, this travels for some distance x with velocity v. So can I simply write it as x is equal to velocity into time? X is equal to velocity into time. Now, if you want to write the equation of the wave, if you want to write the equation of the wave in terms of x comma t, if you are considering this as your reference point now, that as your reference point, what will this point be? This point is negative towards yours. It is towards the negative x direction. So can I simply write it as it is the total distance traveled minus the distance between them. It is v into t. So it will be y will be the function of x minus v t, which implies in place of x you're simply supposed to substitute x minus 2t. If you substitute x minus 2t in place of v, x, you are supposed to write x minus v into t. What is the velocity of the function given? It is 2 meter per second. So x minus 2 into t whole square. So it is option C. Always remember, if your wave is traveling towards in the positive direction, it will be always x minus vt. If it is traveling in the negative x direction, it will be x plus v into t. And going to the next question, question number 13. The speed of the sound at STP will be approximately given as. What is the speed of the sound? It is under root of 3r, is 3rt by gamma. What is the value of it? Is under root of 3 into r. What is r? 8.314 into what is the temperature? The absolute it is temperature it is 273 divided by gamma. What is gamma? 1.4. So it is 1.4. If you calculate, you will get it as 314 change. 314 meter per second. So from in the given options you don't have 314. So the closest value for 314 would be 310 meter per second. So your answer is 310 meter per second. And going for your next question. Question number 4. The time period of a simple pendulum is t. So what's the time period? When the length is increasing by 10 seconds. So like, what is the initial time? After that time period is 2 pi into under root of 10 pi. When the length increases by 10 centimeters, its time period is t1. So can you simply write it as t1 is equal to 2 pi into under root of L plus 10 divided by 2. And its length is decreased by 10 centimeters. It is t2, which implies 2 pi into under root of L minus 10 divided by 2. So can we simply write it as t2 square, t2 by 2 pi, t2 by 2 pi whole square is equal to L minus 10 divided by g, and multiply this thing with t1 square. Just keep it. Don't multiply. Similarly, what you get? You get it as t1 square divided by 2 pi whole square is 4 pi square is equal to L plus 10 by g. L plus 10 by g. Now, if you add this equation and this equation, what do you get? You will get it as t2 square divided by 4 pi square plus t1 square by 4 pi square, which implies this minus 10 and plus 10 gets cancelled out. All you get is 2L by g. But what is 2L by g? From the from the equation, like from this, the very first equation, what you get? Your time period is t square by 4 pi square is equal to L by g. So in case of L by g, you can simply write it as t square 2 into t square by 4 pi square. So this 4 pi square gets cancelled out. So you have t2 square plus t1 square is equal to 2t square. So t1 square plus t2 square is equal to 2t square, which is option C. And going for question number 15. Seeing question number 15. The kinetic energy versus displacement from the mean position graph of the particle performing simple harmonic motion varies as shown below. The mass of the particle is x kg and the angular frequency of the oscillations. We are supposed to find the angular frequency of the oscillation. So what do we know? From this figure, can I simply say the maximum kinetic energy is 12? So like the maximum kinetic energy is the total energy. So the total energy is equal to half m p square omega square. So this total energy is 12 Q1 is equal to 1 by 2. And what is the mass of the body? It is 6 kg, so it is 6. What is the amplitude? This is the main position. The amplitude is 2, so it is 2 square, 2 square into omega square. So 2 and 2 gets cancelled, 6 to square, 1 and 2 gets cancelled, omega square will be equal to 1 and omega will be equal to 1. So it is option D. Here question number 16. The Cp and Cv values denote the specific heats per unit mass. Always remember this, is asking you per unit mass of an ideal gas of molecular weight capital M, where R is the molecular weight constant. Please remove that Cp minus Cv is equal to R. Can I simply write it as M into M into, M into small Cp? We can write it as M into small Cp minus M into small Cv is equal to R. If I take any form, it is Cp minus Cv is equal to R by. So it is option C. Going for question number 17. Heat cannot by itself flow from lower temperature to a body at higher temperature. This statement corresponds to this statement always corresponds to the second law of thermodynamics, which says that if you want to move the heat from the lower temperature body to the higher temperature body, you always replace it with the source. This second law of thermodynamics. Question number 8. What is the dimensional formula for A into B power minus 1? So what is the dimensional formula for B? As we have seen the similar question previously. So the dimensional formula for B is L3. And what is the dimensional formula for A? The dimensional formula for A would be A by B square. B square is nothing but L power 6 should be equal to the pressure by dimensional formula for the pressure, which is M L power minus 1 into T power minus 2. If you write it as A, the dimensional formula for A would be equal to M L power 5 into T power minus 2. What is he asking? He is asking us to find the dimensional formula for A into B power minus 1. This is A, B power minus 1 is L power minus 3. So it is A, B power minus 1 is equal to M L power 5 B power minus 2 into B power, B is L power 3, is L power minus 3. So L power 5, L power minus 3 is M L power 2 into T power minus 2. M L square T power minus 2. It is option B. Going for question number 19. The simple harmonic motion is given by y is equal to 5 of sine 3 pi t plus root 3 cos 3 pi t. What is the amplitude of motion if y is in meters? He's asking, what is he asking? He's asking simply amplitude. So, can I simply multiply and divide it this by 2? If I multiply and divide it this by 2, it will be 5 by 2 into 1 by 2 into sine of 3 pi t plus root 3 by 2 into cos of 3 pi into t. If I write it as what is cos 60? Cos 5 by 6 into sine 3 pi t plus this root 3 by 2 in terms of sine is sine 5 by 6. Sine 5 by 6 into cos 3 pi t. So this is in the form of sine a plus b. You can convert this into sine a plus b and you also have 10 in front. So what's your amplitude? 10 meters, because he said that the y is in meters. If your y is in meters, so this value will be 10 into sine of 3 pi t plus 5 by 6. So your amplitude is 10. That is given as in the form of meters, but your options are all in centimeters. So this would be, if this is 10 meters, this would be 10 into 100, which is 1000 centimeters. Going for question number 2. If the fundamental frequency of closed organ pipe is 50 Hz, then the frequency of second is the fundamental frequency. What is the fundamental frequency? The fundamental frequency of the closed organ pipe. For the closed organ pipe, this is the fundamental frequency. And we saying this length is lambda by 4. And what is the frequency? Say 50 Hz. So can I simply write it as the total length of the pipe. The total length of the pipe is equal to lambda by 4. So your lambda is equal to 4. Now can I write lambda as velocity into time? Velocity into time. Or I will write it as velocity divided by frequency. This is velocity divided by frequency is equal to 4 into that. So your frequency would be equal to V by frequency is V by 4. What is the same? This is the fundamental frequency and this is equal to 50 Hz. This is equal to 50 Hz. Now what is he asking? He is asking us to find the frequency of second overtone. What is second overtone? The second overtone is third harmonic. Second overtone is third harmonic. Third harmonic in a sense. This is your third harmonic. Third harmonic in a sense. It is lambda plus lambda by 4 is equal to 1. So it is lambda into 5 by 4. Yeah. So it is equal to 8. So lambda is 4 by 5. Lambda is not, what is lambda? Lambda is nothing but velocity by frequency. Velocity by frequency is 4 by 5. And here new frequency is 2. So 2 is equal to 5 into v divided by 4 into n. But what do we know? We know that v by 4 is 50. So can I simply write it as 5 into 50? What is 5 into 50? 5 into 50 is 250 Hz. It is 250 Hz. Moving to the next question. The equation of a simple harmonic motion is y is equal to, this is your equation for the simple harmonic motion, y is equal to a sine 2 pi nt plus r. Then its phase at time t is asking phase, not phase difference. We all know that we call this as the phase difference when you are comparing this wave with another wave. But what is he asking? There is no second wave here. He is only asking about single wave, and we say its total inside value is called phase. Phase is nothing but the angle. When you correspond this equation to the reference circle, we call this as phase or phase angle. This total is called phase angle. So the phase at time t is, in case of the substituting, it is 2 pi nt plus alpha. 2 pi nt plus alpha. It is my question number 21. Moving to the question number 22. A man standing on a cliff claps his hands and hears its echo after 2 seconds. If the sound is reflected from another mountain, then the distance between the man and the reflection point is. So this fellow is already standing on a mountain, and there might be some another mountain here. He is clapping so that the sound wave is traveling to this point and it is again coming back. So what is the distance? Can I simply write it as the total distance is that if the distance between the mountains is s, then the total distance traveled is 2s, and this 2s is traveled in how many seconds? He is able to hear the echo in 2 seconds. So can I simply write it as 2s by 2? Distance by time is your velocity. It is nothing but 340. So 2 and 2 gets cancelled. But what is the distance? It is 340 meters. So the distance between the man and the reflection point is 340 meters. Question number 23. The ratio of average translation kinetic energy to the rotational kinetic energy of diatomic molecule. So with respect to diatomic, this is important. This diatomic molecule. So for the diatomic molecule, we have 3 translational degrees of freedom and to rotational degrees of freedom. So with respect to degrees of freedom, you have three translation degrees of freedom, two rotational degrees of freedom. Your energies are equally distributed in all degrees of freedom. If energy is supplied, if you have 5 degrees of freedom, each degrees of freedom will take equal amount, or equal share of energy. So, so the like the what is that, the ratio of translational energy can be converted to rotational kinetic energy. So the energy will be in the ratio of 3 is to 2. This is option B. Question number 24. The bob of a simple pendulum is a spherical. Okay. The bob of a simple pendulum is a spherical hollow ball filled with water. A plugged hole near the bottom of the oscillating bob gets suddenly unplugged. During observation, till what till water is coming up, the time period of the oscillation is asking what happens to the time period if there is a if the water is leaking out of the bob. If this is the bob and water is filled in it, and here is the leaking. From here the water is leaking. As the water is leaking, what happens? Can I simply say the center of mass is shifting downwards? The center of mass is shifting downwards. As the center of mass is shifting downwards, can I simply say that the effective length of the pendulum is increasing? If the effective length is increasing, can I simply say the time period is nothing but under root of L by G? If length is increasing, your time period will increase. What happens? Your time period will increase. Your time period of oscillation will increase. Then, as this water is completely drained out, the center of mass will again come to the same point, because the center of mass of the empty shell is also the same thing. So the time period will again change. So what happens? In, it first increase and then decrease to the original value. So what happens? The time period will increase first until the water is completely drained to the last point. Once it's completely drained, the center of mass will suddenly shift to the original position, and this will be the option 1 will explain your this phenomenon further. So your option is your correct answer. Going to question number 25. The frequency of the tuning fork is 480 Hz, and the fundamental frequency of the string is fixed at over the inch is 400 Hz. The string is excited by the tuning fork. See here, the tuning fork, we cannot change the tuning fork frequency, and he's saying that the string is fixed at both ends. String is also fixed at both ends. If it is fixed at both ends, you cannot change it. You cannot even change the length of the string also. That means you cannot change the frequency of the string. You cannot also change the frequency of the tuning fork. Then how are we supposed to proceed for this problem? Will resonance occur? Will resonance occur? No. There is no point that resonance will never happen. There is no point for the resonance. Resonance does not occur at any cost. So your option 3 says the resonance does not occur, so it's wrong. Option A is also wrong. Resonance does not occur, but the string will vibrate with the given frequency. The string will vibrate with the given frequency. So it's your option B is right. Moving on to the next question, question number 26. The particle of mass m is hanging vertically by an ideal spring of force constantly. If the mass is made to oscillate vertically, the total energy is. We all know that if the mass is made if the mass is made to do simple harmonic motion. This is the vertical simple. This is a vertical mass and it is connected to the vertical spring. If the oscillation is happening, if there is any chance, if you don't consider any air friction or losses, we know that this will be simple harmonic. In simple harmonic motion, your total energy is always constant. So your total energy will be at same in all the positions with respect to of the position. Even if it is vertical or even if it is horizontal, or your energy will be constant in all the positions given. Going to the next question, question number 27. saying that the total internal energy is zero for an ideal gas. Like for an ideal gas can be the best represented by the following graphs. So what can we see is if you clearly observe here, can we simply write it as total internal energy zero? Total internal energy is zero. Can I simply say if total internal energy is zero, that means there is no increase or decrease in the temperature of the body. If there is no increase of temperature, can you simply say the temperature is constant? If temperature is constant, can you simply write it as PV is equal to constant? If PV is constant, what graph, which graph better represents PV graph? So it is option B. Option B is your right answer. Going for question number 28, to make the frequency double of the spring, we have what is the frequency double of the spring oscillator? What are we supposed to do? What is the time period? Time period is 2 pi into under root of L by G. Right? If you want to write it in the terms of K, so can I simply write it as 2 pi into under root of K by M? Sorry, M by K. K into X. Double M into G. M by G is M by K. So it is M by G is M by K. M by K. Now, what is he asking? He is asking about the frequency. This is time period. Time period is directly proportional to M by K. You can simply write frequency is directly proportional to K by M. What is he asking? To make the frequency double? He wants to increase the frequency by 2 times. If he wants to increase the frequency by 2 times, there is a two possibilities. Is he talking about any? Is he talking about the spring? Spring? No, he's not talking about the spring. He's only talking about the mass. If I want to increase the total value by 2, I want to decrease the mass. If I decrease the mass, the total frequency will increase. So if I decrease the mass by 4 times here, by 4, the frequency will increase by 2. So it is reduce the mass to 1/4 each option. See your question number 29. A horizontal cylinder. See your question number 29. A horizontal cylinder has two sections of unequal cross sections. Two sections of unequal cross sections in which two pistons can move free. Which a horizontal cylinder has two sections of unequal cross sections in which two pistons can move freely. The pistons are joined by a string. Some gas is trapped between the pistons. If the gas is heated, in which direction will the pistons move? So, see here, if you're heating you're supplying some heat to the system. If you're supplying some heat to the system, the temperature of the gas will increase. If the temperature of the gas is increasing, what will happen? This gas will try to expand. Gas will try to expand. If you see the diagram carefully, if these pistons are moving towards left, the volume of the gas is reducing. So, but if you're supplying the heat by the natural phenomenon, like the natural phenomenon is for the gas has to expand. For the volume has to expand, this piston has to move towards right. So that the volume is increasing. So this pistons will move towards right. So it will move towards right. Moving on to the next question. Question number 30. A pipe with 30 centimeter length is open at both ends. So he's talking about the length of the pipe is 30 centimeter, open at both ends. Which harmonic mode of pipe resonates at 1.65 kilohertz source? So can I simply say like the fundamental harmonic? This is the fundamental harmonic. What is the second harmonic? Your second harmonic would be this one. And what about the third harmonic? Can I simply write it as this is your first harmonic, this is your second harmonic, and this is your third harmonic. If this is the case, what is this wavelength? Here it is lambda. Sorry, here it is lambda by 2. Here it is lambda by 2 plus lambda by 2. So it is lambda. So it is 3 lambda by 2. So which with each increase in harmonic, what you're getting it as, here it is, lambda by 2 plus lambda plus lambda plus, sorry, no, this is only up to this point, not this point, so it is 3 lambda by 2. So your wavelengths are lambda by 2, lambda, 3 lambda by 2, and 5 lambda by 2, so on. So if this is the case, can I simply write it as 2n plus 1 by 2 into lambda is the wavelength of the resonant wave. If the tube is in resonance, this will be the wavelength produced. So, and he's saying that the resonance produce, what is the frequency of the resonance? 1.65 kilohertz, and this is the wavelength. What is wavelength? Wavelength can be written as, and this has to be equal to the length of the pipe. So 2n plus 1 divided by 2 into lambda. Lambda is nothing but velocity into time. It is nothing but velocity by frequency, which is equal to L. So your frequency is equal to 2n plus 1 divided by 2 into velocity divided by length. If you calculate it, what is the frequency given? The frequency given is 1650 is equal to 2n plus 2n plus 1 divided by 2 into, what is the velocity of sound? It is 330 divided by the length. What is the length of the tube? 30 centimeters. So it is 0.3 meters. Now if you can calculate it, 2 and this will be 165 into 10. So if you if you simplify it, you will get it as 2n plus 1 is equal to 10 into 0.3. 10 into 0.3 is 3. So n has to be equal to 1. So which harmonic, if if n is 0, first harmonic, if n is if n is 0, it is first harmonic, if n is 1, it is second harmonic. It is option it is option A. Moving to the next question, question number 31. Now, in what direction the velocity of the wave is moving? The transverse wave shown in the is traveling from right to left. So it is traveling towards left. If it is traveling towards left, the direction of the instantaneous velocity. Velocity of particle is asking. So what is velocity of particle? Velocity of the particle always oscillates in this direction. So can I simply write it as dy by dt? We can write it as dy by dt. And if we multiply it with dx and dx, if you multiply, this is a shortcut, this is not the actual method. In actual method, you will get a negative sign. So it's a shortcut to remember it. So minus, if you simply interchange the division the denominators, you'll get it as dx by dt. What is dx by dt? Dx by dt is the velocity of wave. So can I simply write it as velocity of particle is equal to minus of velocity of wave into, this is dy by dx. What is velocity of wave here? He's saying that the velocity of particle is, now can you see what is this is y and this is x, and what is this dy by dx at this point? This is negative, so we have negative. And what is velocity of wave? Velocity of wave is going in negative direction, so that is also velocity of wave is negative, and dy by dx is also negative, so your value will be negative. So can I simply say the velocity of particle is moving in negative y direction, negative direction in the sense your velocity is going in downward direction, so it has to be option B. Going for the next question, question number 32. If the velocity of the wave produced in the string is 200 meter per second and the tension in the string is 500 newtons, find the linear mass density. Velocity is equal to under root of T by mu. So what is velocity? Velocity is velocity is 200 meter per second, and what is the tension? The tension is 500 divided by mu. So what is it? It is equal to 500 by mu, which implies 5. So mu is equal to 5 by 400, which implies 5 by 4 into 10 power minus 2. 5 by 4 into 10 power minus 2. So it is option. Question number 33. The mixture consists of 2 moles of oxygen and 4 moles of argon. 2 moles of oxygen and 4 moles of argon at temperature T. Neglecting all the vibrational modes. No vibrations. The total internal energy of the system is. What is the total internal energy of the system? So can I simply write the total internal energy of the system is N into F RT divided by 2. So due to 2 moles of oxygen is diatomic. So can I simply write it as is saying that N is 2 by 2, and the degrees of freedom for oxygen is, for diatomic it is 5 into RT, 5 RT for oxygen. What is the for argon? For argon is an like noble gas. For noble gas it is 2 into the degrees of freedom is 3 into RT divided by 2. So how many moles? So 4 moles, no? So this is 4 moles. 4, 2 into 2. So this is 6 into R. This is for argon. Argon it is 6 RT. For oxygen it is 5 RT. 6 RT plus 5 RT. 6 RT plus 5 RT is 11 RT. I'm going for question number 34. Which of the following is incorrect? Which of the following is incorrect? So we shall see. Like if the wave is longitudinal, it must be a mechanical wave. Yes, it is. If the wave is mechanical, it may or may not be transverse. Correct. You have longitudinal mechanical waves can be transverse as well as longitudinal. Mechanical waves cannot propagate in vacuum. Correct. Diffraction help us to distinguish between sound wave and light wave. Wrong, because both the light waves and sound waves, both waves both undergo diffraction. So this is your wrong option. So this is your option which you are supposed to tick. This statement is wrong. So this is the right answer for your question. There is no loss of energy when the molecules of an ideal gas collide with the walls of the container in which the gas is kept. Yes, because the collisions are in ideal gas. Assumptions of the ideal gas in kinetic theory of gases, of the basic assumptions, the primary assumption is all the collisions which are happening must be elastic in nature. So can I simply say that? Okay, fine. The statements choose like so. Option one and two both are statement one and two both are right, and they both explain it correctly. So it's option A. See your question number 36. The work done in the isothermal expansion of the gas depends upon. What is work done in isothermal process? Can I say it is N into RT divided by ln V2 by V1, if I am not right or not wrong. Yes, it is V2 by V1. It depends upon the temperature. It also depends on the expansion ratio. So it depends both on the temperature and expansion ratio. Going to the question number 37. Two sections of different amplitudes along the same straight line are added together. The resultant SHM has maximum amplitude, the phase difference between. You'll have the maximum amplitude when the phase difference is 0. You'll get it as A1 plus A2 whole square. A1 plus A2. A square is equal to A1 plus A2 whole square. So you find the time period for the uniform disk of mass m and the radius are suspended through a point r by 2 away from the center, oscillating in the plane. So find the time period of a uniform disk of mass m and the radius r suspended through a point r by 2 away from the center. It is oscillating with respect to this position. This is the fixed point. This is the fixed point through which it is oscillating. And what is the distance from the center? From the distance from the center is r by 2. So what is the time period? We know the resultant is the resultant torque. The resultant torque is mg sine theta into the total mass is acting at the center, so it is into r by 2. That has to be equal to I into alpha. Since angles has to be small, the sine theta will be theta. So it is mg into r divided by 2 into theta, which is equal to I. What is the moment of inertia now? The moment of inertia for the disk is moment of inertia with respect to the point of oscillation. We are supposed to find the point of oscillation will be using parallel axis theorem. The moment of inertia with respect to center of mass plus m into distance, m into r, m into distance square. It is mr square by 2 plus m into r by 2 whole square, which is mr square by 2 plus m into r square by 4. So this would be 3 by 2 mr. So 3 by 4 mr square is the moment of inertia. So it is 3 by 4 mr square into alpha. Gets cancelled out, r and r gets cancelled out. Your alpha would be equal to 2, and it will be 2g by 3r into theta. This is alpha. And for simple harmonic motion, your alpha has to be equal, is directly proportional to omega square into theta. So your omega square is 2g by 3r. He's asking for the time period. If omega square is 2g by 3r, your time period would be equal to under root of 2g by 3r. It is under root of 2 pi by t, sorry, 3r by 2g, under root of 3r by 2g. 3r by 2g, option C. Question number 39. The wave disturbance in the medium is described by y is equal to x comma t at is equal to 0.04 cos so and so and cos 10 pi x, where x and y are in meters and t is in seconds. He's asking where the node is occurring, where the antinode is occurring, and what is the speed. And he's also saying that options like all of these are not. We shall see what is node. What is node? We can I simply say the node is a point where um, your y is 0. Your y has to be 0 at node. If y has to be 0, can I simply say this value has to be 0? If cos 10 pi x has to be 0, can I simply say this cos 10 pi x has to be equal to 0? So in that case, this 10 pi x can be equal to pi by 2 or 3 pi by 2 or or 5 pi by 2 and so on. If you calculate it, what are the x values you get? You get x nodes as pi by 2 divided by this pi gets cancelled out. The pi gets cancelled out. If pi is getting cancelled out, x is equal to 1 by 20 or 3. X is equal to pi by 20 or 3 by 20 or 5 by 20. What is 1 by 20? 1 by 20 is 1 by 10 is 0.1, 0.05. This is 0.05. This is 0.15, and this is 0.25. So your node occurs at 0.15, correct? And when does your antinode occur? Your antinode occurs when the same antinode is nothing but when this value is maximum. So this y value has to be equal to +1 or -1 or plus or minus maximum value 0.04. So can I simply say this value has to be equal to +or -1? Only then your antinode occurs. So it will be cos of 10 pi x has to be equal to +or -1. So what is this 10 pi x? 10 pi x has to be equal to, it is equal to +1 when it is equal to 0 or pi or 2 pi or 3 pi and so on. So if you cross pi, so can I simply write it as x is equal to 0 or 2 by 10 0.2 comma 0.3 comma if you write it, if you keep on writing 0.4 and so on. So at all these points your antinodes will occur. So can I simply say, excuse me, in the given thing, what is he saying? The antinode occurs at x is equal to 0.3 meters. So your option A is right, option B is also right. In the net, like we know that if these two are right, this will also be right. So in all of these, so how do you find the velocity? Why should we leave this? So the velocity would be equal to lambda by t. So lambda by t is nothing but 2 by omega by k. If you write omega by k, what is omega? K, omega is 50 pi by k. What is k? 10 pi. It is 5. The velocity is 5 meter per second. So all all option 1, 2, 3 and are right. So your option 4 is the right answer. Going through the question number 40, hydrogen assume at room temperature kept inside a box has E. What is hydrogen? Hydrogen is diatomic gas. So what is the energy it has? The energy is F into N by 2 into RT. So if somehow the hydrogen disassociates to form a nanoatomic ideal gas, the temperature is same. There is no change in the temperature. The new energy is. He's saying that now each mole is disassociated into two different moles. So that means 1 mole of hydrogen gas has become 2 moles of monatomic gas. So can I simply say your initial N is 1. If N is equal, E is equal to N, the degrees of, when it is diatomic, it is the degrees of freedom is 5 into RT by 2. Now, thus for the say in the second case, the energy 2 is the number of moles has become double 2N, and the degrees of, now it is a monatomic gas, so the degrees of freedom has to be 3 into RT divided by 2. 2 and 2 gets cancelled out. So what is nRT? nRT from this, N into RT is equal to 2E by 5. So we also have nRT here, 3 nRT, 3 into nRT. nRT is nothing but 2E by 5. So can I simply write ET is equal to 6E by 5. So your E dash, your energy, the final energy of the system is 6E by 5. Going for question number 41, the gas absorbs 18 joules of heat and work done on the gas. Means he's giving the energy, he's also doing the work. So that means what is the total energy supplied? Energy supplied in the form of heat is 18, and what is the energy supplied in terms of work? 12. So what is the 30 joules of internal change will be there, and that is your option D. Here question number 42. The ratio of speeds of sound in hydrogen gas to the speed of sound in oxygen gas at the same temperature is. What is the velocity? Velocity of the gas is under root of 3RT by under root of 3RT by m. Yes, and we know that, can I simply write it as velocity is inversely proportional to the mass. Now, the ratio of speed of sound in hydrogen gas. Hydrogen gas is H2. The mass velocity of hydrogen gas to the velocity of oxygen gas is equal to under root of mass of oxygen divided by mass of hydrogen. It is under root of 32 divided by 2. It is under root of 16. Root 16 is 4. So it is 4 is to 1. Option A. Going to question number 43. Two springs are connected to the mass as shown in the figure. Find the frequency of oscillation. What is frequency of oscillation? The frequency of oscillation is 1 by 2 by under root of k by m. Now here two springs of same spring constants are connected in series. If they are connected in series, the effective spring constant would be 1 by k plus 1 by k. So the k effective would be equal to k by 2. So the frequency would be 1 by 2 pi into under root of k by, and we shall move to the next question. K by 2m is option B. Two sinusoidal waves were given below are superimposed. The equation for the resultant wave. Now, if you observe this question carefully, see here what is the phase difference. This is plus by 6, plus pi by 6, and this is minus pi by 6. The remaining values are same. So, can I simply say if this is the normal thing, this the first value y1 is at with pi by 6 here, and what is y2? Y2 is also there with the same pi by 6 but in the opposite direction. Now, when these, since the angles are same, they'll impose on the x-axis itself. If they are imposing on the x-axis, the amplitude of this is a, the amplitude of this is a, and pi by 6 is nothing but 30 degrees. A cos 30 is root 3 by 2, so it is, the amplitude is root 3 a by 2 plus, and due to this also you'll have the same thing. It is root 3 a by 2. Root 3 a by 2 by uh, root 3 a by 2 plus root 3 a by 2 is root 3 a. The resultant amplitude of the system is root 3 a, and it is on the x-axis. If it is on the x-axis, the phase difference, the phase difference has to be 0. So in these two things, the phase difference is there, so it has to be 0. Now if you observe these things, what is the resultant amplitude we got? It is root 3 into a. So only this equation has the right thing, and the phase difference is also not mentioned here. So your right option is option B. Go to your question number 45. Now, the wire of length 2L is made by joining two wires A and B, and A is of radius R and B is of radius 2R. It is vibrating at a frequency such that the joint, the last question. If the number of it is vibrating at a frequency such that the joint of the two wires forms a node. If the number of antinodes in wire A is P and that in B is Q, then the ratio P is to Q. You are supposed to find the ratio of antinodes in P and Q, or the nodes in P and Q. If you clearly observe it here, so what is the velocity? What is the velocity of the velocity of the wave is nothing but t by mu. Velocity of the wave is nothing but t by mu. Now, if you carefully observe, we know that if a light wave is traveling from one medium to another medium, the frequency will remain same. But in if can I simply say that where is the density smaller? Can I simply say the density is smaller in the first one? So can I simply write it as velocity of A by velocity of B is equal to under root of mu B by mu A. Now, what is the density? Density is nothing but length per unit area. Now, if you observe it, the lengths are same. Only the cross section area is same. So, can I simply write it as which is equal to pi? What is the cross section area for this? Pi r pi. For B, it is 2r square. It is 4 into r square divided by pi into r square. So, it is velocity of A by B is 2 is to 1. Now, we know that the frequency is same, but the velocities are different. The velocity of the wave in A is much bigger, and velocity of B is smaller. So, can I simply say the frequency is same? If frequency is same, that means the time it is taking to cross, go up and down, is always same. But since velocity, when you talk about the wave velocity is much greater in A and the wave velocity is much smaller in B. So can I simply say that the number of nodes formed will be more where the velocity is smaller, because it is not traveling forward, but the frequency is same. It is moving up and down in the same with the same frequency, but it is not moving faster in B. So can I simply say the number of nodes which are formed in B will be more, and the number of nodes which are formed in A will be smaller, and that will be in the ratio. The number of nodes or antinodes which are formed is inversely proportional to the velocity. So it is velocity of A by velocity of B. Is asking the ratio of P and Q. So it is Na by Nb. Va by Vb is 2 by 1. So Na by Nb is 1 by 2. So it is option B. Thank you so much.